Hello, everybody. Today we're going to deal with inequalities, which is 2.8, chapter 2, section 8 in the book. So, you might have seen some of these before, but let's review our inequality symbols. So, greater than, right? We have less than, greater than or equal to, right? The or equal to is the bar underneath, and less than or equal to. Okay. So, remember that the inequality always opens. So, like the part that opens, this part here, always goes on the side with the bigger number, and then always points to the smaller number, right? Some people think of it as like alligator mouth, right? All right, where the alligator always is hungry, so it wants to eat the bigger number, right? Okay, so probably the most beautiful alligator I've ever seen. Anyway, and remember that you can kind of read these forwards and backwards. So if I say x is greater than 2, I can also think of it as, okay, well, 2 is less than x if I read it from right to left. Okay, so the pointy side goes to the smaller number, the open side goes to the bigger number. All right, so let's check out some examples. Oh, and by the way, the or equal to means the number could be that number, or it could be bigger or smaller, right, depending on if you used less than or greater than. In this case, x is greater than or equal to 2, so it could be 2, or it could be anything bigger than 2. It could be 2.1, 2.01, 2.5, 3, 100, a million, etc., right? Okay. All right, so here's some examples. So determine whether each of the following statements is true. So basically we're just looking to see if, okay, is this inequality pointing to the smaller number? Is it opening to the bigger number, etc., right? So here, this is claiming that -5 is less than -8, right? Is that true? And the answer is no. -8 is less than -5, right? So, all right, I'd rather owe someone $5 than owe them $8, right? Owing someone $8 is you're more in the hole than owing them $5. Okay. So anyway, that means this is false. All right. Number 2, is -6 greater than -3? Is -6 greater than -3? And the answer is no, right? -3 is greater than -6. So this would also be false. So it's always tricky with negatives, right? All right, now number 5, it's saying that 4 is less than or equal to +4. Or, +4 is less than or equal to +4. Is that true? Yes, it is, right? Because remember, it's or equal to. In this case, they are equal. So that's true. Now, if they said 4 is less than 4, that would have been false, right? So if I said this, that would be false. Okay, so the or equal to includes the number, whereas if you don't have that, it doesn't include the number. All right, now in 13, we have an expression that we can simplify, right? So we have -4 times 5 minus 6, so that would be -20 minus 6, which would be -26, is greater than or equal to 5 times -6, which is -30. So is -26 greater than or equal to -30? The answer is yes. So that's true. Right? So smaller absolute value negative number is larger than a larger absolute value negative number, right? Okay. So then we have another one that's similar. We're going to evaluate this. So -12 plus 12 is 0. And is 0 less than or equal to 2 times 3 is 6 minus 6 is 0. So we get 0 on both sides. Is 0 less than or equal to 0? The answer is yes. It's true. All right. So that's one type of problem. So here's another type of problem. Here they're asking us to state the solution set in interval notation and sketch its graph, right? So let's start with the interval notation. So here it says x is greater than -2, right? So if x is greater than -2, then how far does it go? Or what are the numbers it could be? It could be -1, right? Is greater than -2. It could be 0. Think of one yourself, maybe. Yeah, it could be anything positive, right? 1, 2, 10, 100, 1,000, million, etc., right? So it could go up forever, right? So our right side of our interval notation is going to be infinity, and we always put a parenthesis with infinity. On the left, -2, right? Can't go less than -2. So, and since we have just a greater than but no or equal to, we're going to use parentheses, okay? So let me write this over here. So if you ever have a less than or greater than, you use parentheses, okay? If you have a or equal to, you're going to use brackets, okay? All right, so now that's our interval notation. Now let's graph it on the number line. So we have a -2 is our endpoint, right? So we're just going to start somewhere at -2. So let's just call this 0, 1, 2, 3. And I'll go -1, -2. Okay, so for us, we're starting at -2. And by the way, let me do one more thing with this. If you have parentheses, that's an open circle on the number line, and brackets are a closed circle, okay? So all those work together. So since we have a less than, that's going to be an open circle. So we can either put an open circle here, okay, and then it's going to go forever this direction, so we're going to draw an arrow that way. The other thing you can do is, instead of writing open circles, you can actually put a parenthesis right here, okay? So that works too. So either way, either open circle or parentheses. Don't put them both, just one or the other, even though I know I would put them both. So that's how you graph inequalities, okay? So for 27, x is less than or equal to 5/3. So when we're talking about interval notation, x is less than, right? So that means it's going to go all the way down to -infinity. It can be anything less than. So that goes, anything less than 5.3, including 0, 4, 3. All those are less than. All the negative numbers, right? All the way to -1,000, -1,000,000, -1,000,000,000, etc., etc. So it goes all the way down to -infinity, and then it goes all the way up to 5/3, right? That's as high as it can be. And then since it has an or equal to, we're going to use brackets. Okay, so there's our interval notation. When we're graphing this on a number line, so if I have, let's scoot this over a little bit. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, -1, -2. So I'm going to start at 5.3, which is a little bit closer to 5 than 6. It's a closed circle, or you can put a bracket, right? Okay. And then this time, it's actually going the other way, so I should turn my bracket around. Okay. And then it goes all the way to -infinity. All right, here we have a compound inequality. We have a situation where we have -3 is less than x, right, is less than 1. Or we can think of it as x is greater than, right, if we read it right to left, x is greater than -3, and on this side, x is less than 1, right? So we can think of that as two different inequalities, right? So you don't have to write this down, but x is greater than -3 and x is less than 1. Okay. So if we're graphing this on the number line, let's write in our values. So since we have positive and negative kind of balance a little bit, we'll put 0 in the middle. Okay, so then since we have a less than at -3, we're going to use parentheses or open circles, right? So I'm going to kind of switch to just writing that instead of the open circle. We'll just do the parentheses. So at -3, I'm going to have a parenthesis. X is greater than that, so it's going to start going this way, right? And then on the other side, we have X is less than 1, right? So once again, that's parentheses. And so I'm going to put parentheses here at 1. And it's less than, so I'm going to start going this way. So where all that meets, that's the interval. Okay. So that's your answer. Oh, and I forgot to put an interval notation. So interval notation is pretty straightforward. It looks just like what we just did, except we're just going to put the -3 and the 1 in there. All right. For 32, similar situation, right? Same two numbers. What's the difference? You guessed it. This means brackets. Okay. So what we're going to have in interval notations, we're going to have -3, comma, -1 with brackets instead. And then it's going to be the same number line, except this time we're going to have brackets or closed circles if you want, right? Either way is fine with me, but we'll start just using the brackets and parentheses. All right, there we go. All right, one last one here. So now we have mixed symbols instead of having both less than or both greater, or excuse me, or both less than or equal to. Now we have a less than and a less than or equal to, right? So in interval notation, that's pretty straightforward. It's just going to be 40. That's our low end or our low end point, and then our high end point is going to be 100. Okay, and this one has parentheses. This one has brackets. So when we graph that on number line, you don't necessarily have to draw every point in between. You can just put 40 somewhere and 100 somewhere, right? And then on one end, on the 40 end, you're going to put parentheses. On the 100 end, you're going to put brackets. That's all the points in between, right? So remember that this interval notation represents all those points, right? So everything that could be in this interval that could be true for X, right? So X could be 50 and it would make it true. X could be 41 even. It could be 99. It could actually be 100. Can't be 40 though, right? Because 40 is not less than 40. So, but 100 is less than or equal to 100. All right, so 36. This one we want to, for interval notation, we're going to go 0 to 600. Those are two endpoints. This means we're going to have brackets. So that's the left side. And then the inequalities doesn't have an equal sign or equal sign. And so we're going to use parentheses. All right, and then when we graph it, same thing. We just put 0 somewhere, put 600 somewhere, and brackets on the 0 side, parentheses on the 600 side, everything in between. Okay. All right. So let me know if you have any questions. You can send them my way via email or Google Voice on the text, or you can text on Google Voice.